Hello. Hello.
You're able to hear me, Raja Reddy?
Yeah, now it's possible.
Okay, fine. Thank you.
Yeah. Can you wait for some time? We'll go for some introduction session.
Yeah, sure.
Good morning, everyone. Well, I welcome all for the fifth day of faculty development program and recent trends in material technology. Today, our guest of honor is Dr. Kirti Shekhar, who is also popularly known as Shekhar Dikshit, CEO of Rishi Tech. Shekhar Dikshit is ex-DRDO aerospace scientist with qualification BE, MTech, MS in Quality Management Systems, Diploma in T&D, and Diploma CAD/CAM, worked in HAL, DRDO, IBM and Honeywell for 25 years in India and abroad. He is an international certified aerospace auditor and Six Sigma black belt. Worked in USA, Europe, and Asia continents. Founded Rishi Tech, an enterprise for software development training services, and business analytics. Expert consultant in aerospace components, design and manufacturing. He is a professional in L, his professional experience in LCA, Airbus, Jaguar, Kirin and Boeing component manufacturing with integrated manufacturing and rapid prototyping. His expertise include wing, front fuselage, fin and rudder structural components, parametric modeling, and kinematic analysis. International Certified Aerospace Auditor for AS 9000, ISO, and CMI quality systems. In Honeywell Aerospace, worked as he led several initiatives like implementation of Six Sigma and lean manufacturing, developed and implemented aerospace process systems to enhance security and business operation excellence across India, China, and Brunei centers. As a corporate trainer, trained more than 6,000 in soft skills, quality, Six Sigma, lean, and project management areas. From past 6 years into quality assessment and process improvement, business analytics, ISO and AS certification, project management, and corporate training. He is into spiritual engineering, energy healing, Vastu, numerology, astrology, and Ayurveda through Dikshit Wellness Center, Bangalore. He is an expert consultant in career guidance for students and professionals in selecting courses or areas of success, selecting the employees and employers a better career options like business or professional front, energy management in homes and business establishment. So it's indeed a great pleasure introducing today's guest, who is a versatile man, and to my knowledge, he touched upon all sorts of knowledge barriers. Really, thankful for him for accepting the call within a short time period. So I call upon Mr. Shekhar Dikshit to continue with the session. You can unmute.
So thank you, Raja Reddy, and all of you welcome. Good morning to all of you. I will share my PPT. Give me a second.
You can share the PPT now.
Yeah, I'm sharing. Are you able to see my PPT? Hello,
Not yet.
I'm sharing now. Just you please check it.
Yeah, now it's visible.
Okay, thank you. Thank you very much. So good morning to everyone. See, normally when the word you listen, aerospace or airborne, you feel a kind of thrilled, some kind of different experience because it is not that much a normal kind of thing. So that's why people will feel it is something different. Also, any airborne object, any man-made other than natural, any man-made airborne object should follow certain conditions, rules and regulation. It is not possible to just to fly whatever we manufacture or whatever we want. It is not possible to fly. In the entire world, there is every country has some certain rules and regulation, and all those things should be followed. Now, what is the critical challenges if you go for the aerospace material? See, first of all, as I told, we cannot use the aerospace material as we like in automobile or any other applications. There is a restrictions, safety precautions, safety standards, government rules and regulations, and government validations. So a lot of other things should be followed. This is the very first challenge in using the aerospace materials. Along with that challenge, we also see the opportunities. The manufacturing industry is boosted by engineering innovation in aerospace and aerospace material. If we see the history from World War I, especially in the World War II, a phenomenal growth in the aerospace industry we can witness, especially started in Germany, a huge demand for bombers. They used to manufacture a aeroplane or a bomber like they are manufacturing a bicycle at that time. So that was the huge requirement. And that is one of the key thing. It made Germany to stand a number one in the aerospace, also in the metallurgy. Because for the materials, metallurgy is very, very important. This any innovations or any challenges will lead a growth in all other industries. First, it will go to automobile industry, then it will go to biotechnology or health industry, then it will reach to the a common person. One example you can see when I was working in NAL on the LCA project in around 92, 93 times. That is the first time we brought that word FRP. Till that, it is not much coined anywhere in the industry, especially in the aerospace industry. With the help of Dassault system from France, we started developing the wings because wing is the one of the most critical aerodynamic surface requirement part. Very
Hello.
difficult to. Hello.
Hello.
Yeah.
Sir, can you please present it in a slide show mode?
It's already in slideshow mode only. It's already in the slideshow mode only.
No, now it is coming in different format here. The, we want
See,
entire
now this is
screen to
the
be
normal format,
okay.
and this
Okay, no
is
problem.
and now this is the slideshow mode. Okay, shall I continue?
Yeah.
See, at that time, nobody knows about the FRP. What is FRP? How to use that? Nobody knows that. We went to France. 1 year we got trained. Our people, scientists stayed there for 1 year. They were trained how to use the FRP, minimum basic knowledge about the FRP,
We
and how to
can.
manufacture the FRP components and all. After 1 year, we came back to NAL. There was a CFC wing division formed, newly formed, to manufacture the wing components for the light combat aircraft LCA project. The thing is, at that day, after we came, we established all the hangars, jigs and fixtures. Material came from the France. Even few scientists and people to help us also came from the France. First wing molding we did, and we're happy to see that physically. Oh, it came fantastically, but the material properties were not met. Even the French scientists, they struggled hard to know what is the root cause. Even they were unable to find what is the root cause. We struggled a lot because it is 400 crore project. We couldn't able to succeed after 2 years. It was a total disappointment. See, finally they went back and they checked. Everything is fine. All the manufacturing condition, laboratory conditions, parameters, everything is fantastic. But finally we found what is the problem means the materials, epoxy resins and other materials, when it was transported from France to India, it will take approximately 3 to 4 weeks of the time. During that, material properties used to change because of heat or whatever. So, during the transport, the properties got changed. That is where we were unable to get that same quality components. So again, they have to do the research and they have to increase the material properties such that when it reaches to India, we should be able to manufacture with the right properties. That day, I remember about the FRP. And now, if you see, on that day, mainly it is tried. There were some small local applications were there, but mainly it tried for the aerospace industry. And after 8 to 10 years, most of my people working in the NAL or HAL, they quit their job. They quit their job, they started their own FRP industries. I remember first time my colleague, he quit, he started a bumper manufacturing. First he supplied to Hindustan Motors, Ambassador car. Earlier that bumper was either rubber or plastic, but now they started the FRP. So like that they started the FRP application. Now it came today in 2020-21. They started using the same technology in the house construction or the pillar construction to reduce the iron and to increase the strength of the pillars to reduce the cost. Now they started using for the
Sir,
pillar construction.
sorry for disturbance, sir.
Yeah.
Sir, at the top, slideshow is there, no, sir? Just you click on slideshow, sir.
See, I'm using the same slideshow only. See,
Once,
see slideshow from present.
correct, sir. Click on. Sir,
Sir, you can cancel it, sir, actually. You can go for the top from current, sir. In top, sir, from current slide. You can click it, sir.
Exactly the same thing I did, madam, current sale only. See, this is the one that it is coming maximum. So what is the problem? I'm not able to see your problem.
Okay, sir, no problem, sir. You can continue.
Okay. Because I know the presentation, normally we will put in the full slide only. Okay. See, now it is started using in the home building industry. Means, if you see from 92 to 2022, in the span of 20 years, FRP or fiber covered the entire world, including medical, it covered entire world. So like that, any innovation in the aerospace industry, because of the greater demand of the aerospace requirements, but slowly, if you develop anything for the aerospace, finally it will go into a common man. It becomes the household requirements. Why I gave this example means investing on the development of aerospace material or aerospace manufacturing, components manufacturing will definitely not only limited to the aerospace, but it will be applicable to every sector. Finally, it will reach to every common man. So now, if you see increased demand for commercial air travel, commercial space travel, and rise in the defense spending. If you see the budgets of the defense budgets of several countries, India is fourth position in the world for the defense budget. And if you see in India, not even 10% of the people are affordable to use commercial air travel. Commercial space travel is just little bit away for the India, but it is started in the entire world. Like that, if you take 75% of the countries in the world, they are not even covered 10% of their travel by air. Okay. And also, if you see, almost 90% of the countries in the world, they are very, very far in the space technology, scientific space, not even commercial space. And if you see the huge demand in upcoming defense requirements, the changes happening in the war field, war technology, if you see all these three critical areas, there is a tremendous growth and potential growth in the aerospace industry. Why this is important means, see today the people who are working in the research area, development area, and manufacturing area, and the people working in the universities, engineering colleges, they need to give more importance to develop this material and solve these industry problems because this will cover to the entire world. And also now you see the latest changes, what is going to happen is there is a total shift from chemical based fuel to electrical energy, including the flying of aircraft. You might have seen from past 2 years, solar powered aircraft successfully tested. In future, it is coming. All the automobiles. As per me, in another 20 years, all the possible moving parts, will try to use the electrical energy. There's a total shift. Now, whatever you see in the rocket launching or going to space or launching the rocket to position the satellite, all those things will not based on the chemical. You are not going to see the dense smoke anymore else. That fire, sparks coming, fire coming, the colorful shuttle, that smoke you are not going to see anything, no smoke at all. Even from the automobile or the jet or whatever it may be, everything will become electrically powered. Such a huge shift is going on. Already railgun technology started. Most of the Israel and US and Russia in the war field, they are developing the guns, tankers. Everything is based on the electrical. There is no chemical. In the future will be, you might have seen recently in the war, how much they're dependent on the laser for the protection. So totally there will be a shift in the basic fuel, and electric in the energy will become the so predominant. When you see from this perspective, now the material what we use in the aerospace or the aircraft has to be changed, because rather than anything, the material property to sustain that electrical energy impacts, influences, conductivity, resistance will become predominantly applicable in this industry. So this is third main aspect of the opportunities, also the challenges. Next, if you see the combination of a growing consumer base and low operating cost to benefit aerospace components and material manufacturers and the original equipment manufacturers in the future. As already I told, only 10% of the people in 90% of the countries are using the air for travel. And space travel, commercial space travel, not even 1%. Can you imagine how much consumer base will expand? The main difficulty in expanding the consumer base is the operating cost. In India also, several companies try to bring a lower operating cost of the aircraft. When you are able to operate in the lower operating cost, mainly the operation cost will include the fuel. When you achieve this, automatically consumer base will expand. Once the consumer base start expanding, then there is a huge growth. In an effort to reduce the operating cost, always our engineers are very pressured, because they have to develop the more fuel efficient aircraft. Only here the key thing is weight of the aircraft and easy assembly. For that, now several type of composite materials are introduced to solve the weight problem. But in the future mode of operating is not only the weight problem, not only the fuel problem, because the basic fuel itself changing, there are several other associated problems will pop up. For nearly a century, the aerospace industry has relied primarily on aluminum (1995). Sorry, this is 1915. There is a mistake here. This is 1915. First aircraft so manufactured like a flying machine in 1915. From that starting point to reduce the weight, mostly till recent past 20 years, all the machines are developed mostly from the aluminum. When I was working in HAL, CNC aircraft division, our aluminum scrap turnover will be around 400 crores per annum. So can you believe this? Just aluminum scrap, the turnover will be 400 crores per annum. You believe or not, the people used to enter illegally and in different ways to steal the scrap, aluminum scrap itself will amount to around 15 to 20 crores. So many times security people shot. And as I know, when I was there, 4 or 5 people died also. Because night time thieves used to jump the compound and they tried to steal the aluminum scrap. Means you can imagine how much aluminum were used. And there is a biggest challenge at that time is the raw material, aluminum raw material, we used to call that as a billet, used for the structural components. That nowhere we used to get that supply except US and Germany, especially Germany. Germany is the number one in the metallurgy. Only they were able to manufacture that kind of a high quality material. And you know, to get that material imported to India, for example, one fuselage frame, to get that much material to manufacture one frame, we used to work for 2 years. We used to pay the money, we used to pay the insurance, all other things, just to get the material 2 years. Then manufacturing, design, proving, finally it goes to assembly. Parts somewhere it used to take from 1.5 to 4 years. I'm just giving a picture to you how much time it will cost. Even today, suddenly war declares, you have to think to manufacture the new combat aircraft, how fast we can manufacture the aircrafts, bombers, or combat aircraft. That is a key thing. For that, key materials, where we need to get the material. Is it possible to manufacture by ourselves, or which country we have to import? Who that country is our friendly country or not? Lot of other behind aspects will be there. When you see these restrictions, sanctions, all those things, it happened in the LCA after our atomic bomb that we tested in the program. Suddenly USA imposed sanction on India. Our LCA project or Tejas aircraft project were delayed for 4 to 5 years. They denied the technology for testing the aircraft. Almost all we lost more than 600 crore rupees. What the money we paid, we didn't get that back because we have to test our software on their structure. Everything we lost. Okay. So like that, a lot of things will be there. When you pursue those prospects, developing indigenous material and becoming independent in the aerospace industry is very, very important. In future, the relationship between the countries and other resource sharing globally is going to change. It is not like that for these 40 years. When you see this perspective, which country leads in the aerospace technology, they rule the world. So far also only those countries ruling the world. You know, for example, even today, a commercial aircraft, passenger aircraft like Boeing or Airbus, except China, no other countries are capable to manufacture and operate. Recently in India, around 15 to 20 seater small crafts, indigenous craft, they started using. Commercially, they started operating in last month in the East India region. But if you see today, even we want a passenger aircraft, we need to go to Boeing or Airbus. We don't have any other choice. But what is the population of India? What is the expansion growth in the commercial travel? If we consider that, how many aircrafts we need, how much money we need to spend on that, this is another primary factor we need to consider in the opportunities. But you know, around 20% pure aluminium. At that time in 1915, it was 100% aluminium. No question of alloys, no question of composite, no question of other material. But today, if you see after 100 years, it drastically reduced. Only just 20% of pure aluminium and most of the non-critical structural materials like the paneling, aesthetic, interior, all those are now started with the lightweight carbon fibers and honeycomb material. Means 80% of the aluminum requirement in the aerospace industry reduced. Also, if you see that globally, earlier for ships, marines, nowadays we use the aluminum alloys for the engine components, even for a submarine. Okay, these aluminum alloys are developed for the aerospace industry. The same thing now we are using in the marine industry, especially the submarines and the huge ship. So the horizontal expansion of the aluminum alloys and demand of new aluminum alloy development also a huge demand. For engine parts and critical components, new alloys and combination of material used for the lower weight and higher temperature resistance for better fuel efficiency in the aerospace industry. But if you take the automobile industry and the marine industry, the corrosion, erosion, lightweight, easy manufacturing, all other factors also will matter. So totally working in the alloys, material alloys and composition will be the future. It has a very huge demand. These factors made us previously impractical to machine or impractical to use that in the aerospace industry. For example, my own experience for the LCA project, we want to reduce the weight. Landing gear is the key component in any aircraft. It's very, very critical. If landing gear don't work properly, then we cannot assure anything. For us, rather than while taking off, that landing gear assembly, it should go inside. That is the key factor. Rather than that, in the landing, it should come out and take a proper position and take proper load. It should function properly in the landing. That is more critical. We cannot compromise anything in the landing gear. So there at that time, aluminum alloy usage is adding to the weight of the Tejas aircraft. We tried to use tungsten material. The challenge was machining the tungsten carbide tools, manufacturing the required tungsten carbide tools, and machining the tungsten is the biggest challenge. So finally, a percentage of tungsten parts and a percentage of aluminum alloy parts were used. Another critical thing is braking system. When you apply the braking for any space shuttle or aircraft or anything, a huge current up to 3,800 degree Fahrenheit or 2000 degrees Celsius will develop. How to withstand that much temperature for a very less time? For example, this temperature will develop anywhere from fraction of second to maximum a minute or two. Within that small short of the time, the temperature should be dissipate. It should cool down such that it should not impact the properties of the braking drum or material of the braking system. And nowadays, if you see another challenge is all the aircraft speed, it is going more than the sound speed, double of the sound speed. Normal commercial travel aircraft itself nowadays are capable to fly in double the speed of sound. When it goes to the combat aircraft, it will be 4 to 6 times sound of speed is required. When you want to manufacture such a high speed flying machines, what about the corrosion, wear and tear? What about the natural electricity conduction, like a lightning or any other thing? All these things will be influenced very critically. If you see the now modern major industry demands, this is the first thing, heat resistance and lightweight alloys. To develop the, especially the engine components, alloys, nickel alloys, and non-metal composite material like ceramics, most widely used. Still, this, what is the innovation happened so far today is not able to fulfill total material requirements. Always I suggest for all the people in the field, try to do your research, your PhD or your research for material development or whatever it may be, by keeping point this first primary factor. Second is composite material. To reduce weight and easy manufacturing of aerodynamic surface. The biggest challenge is the aerodynamic surface. And here, composite materials are lightweight, which enable manufacturers to build aircraft that are more fuel efficient, ultimately safe for passengers. Composite material, it is the metal or plastic or whatever it may be, using in the aerospace industry will be doubled in every 5 years. Okay, this usage will be doubled, 100% increased in every 5 years from the past history. Then can you think of how much opportunities are open in the composite material? Most widely used a carbon fiber, a glass and aramid reinforced epoxy. Carbon fiber composite blends are most widely used for growth and innovation. See, this is the another predominant area nowadays based on the composite material, mainly for the health industry. These materials are used, for example, to make the artificial bones, and in the dental industry, our teeth, bones, also some parts of the heart, walls of the heart, bones, structural components. A predominant application found in the health industry. Like that, if you see, there is a very much opportunities also to develop this material to particular industry like a refineries or like health industry or for marines or for ordinary usage will have its own challenges. Next, nanoparticles. Many times it is not only heat resistance but withstanding the electrical forces of nature is very important. When you fly in the aircraft, you will experience the turbulence. You experience the forces. So far, we were unable to analyze a total all the forces in the nature or how force will act, how it will work. So predominantly, we were able to build a safe machines, but still there are a lot of things are there. As the environment changes, these kind of natural forces also will keep on changing. We need to consider, so developing the materials from that perspective These nanoparticles, metal and matrix, this is known as the reinforced metal matrix composites, are one of the most important because of their high tensile strength and electrical conductivity. There are several other types of nanoparticle being used, including polymer and ceramic based versions. Nanocomposites are the material of 21st century having an annual growth rate of 25% due to their multifunctional capabilities. When they have an annual growth rate of 25%, then can you imagine how much is the opportunities, business opportunities, development opportunities? The saddest part is most of the universities, most of the colleges, most of the students, they do the engineering, they complete the mechanical, aerospace, metallurgy, material science, everything. They try to see some job. And most of the people nowadays will shift to the software. Because they get a job in this field, they don't realize the future requirement of their own core field, strength, and future opportunities. For time being, salary point or easy a perspective point, I have seen most of the dentists are working in the call centers. This is another biggest challenge for us to retain the people, the core people, and continue in the core engineering field such that they have a bright future. Chemical property like resistance, passiveness to corrosion is the primary importance in aerospace and marine industry, apart from the lower weight. And here, mechanical properties like strength, toughness, fatigue life, impact resistance, and scratch resistance are very, very important. Especially in the flying object, there will be a cyclic load. Any moving will have more cyclic load. So this is the critical requirement. Fatigue is the critical requirement of this industry. Next, fourth is graphene. Graphene is a nanomaterial arranged in a two-dimensional layer of carbon atoms with sp2 hybridization that are connected in a hexagonal lattice structure. Almost all of you know about the graphene. Just I put the little bit more on that to understand what is a graphene in case if you don't know. Graphene is a material more and more manufacturers are incorporating into their design because of the variety of electrical applications. As I told, next entire basic fuel itself will become electrical energy. Then everywhere electrical application is very much required. For one, graphene is used in epoxy resins that boost the electrical conductivity of carbon composites in the fuselage. Fuselage is the aerospace or aircraft component. You can see that dome-like structure that is called the fuselage. Front fuselage, middle fuselage, and rear fuselage. The aircraft industry relies heavily on the composite material, and lightning strikes pose a big risk as composite tend to be inert and need to be more conductive. This is another biggest challenge in the flying objects. So now coming to other challenges in the parts manufacturing, cost of material, sourcing of material, development of quality material, the chemical composition, metallurgy is very, very challenging and very, very critical. But now if you see the use of composite materials or FRP materials, other chemical-based material, the manufacturing of metal alloys, production of the metal alloys is reduced, and that complexity also got reduced. Because after 2 years waiting, when we get the aluminum alloy material for manufacturing of aircraft components, if it fails in testing, because we have to do ultrasonic testing and all other X-ray, all other kind of testing to study the structures. microscopic structure. If it fails, then after rejecting that material, again we have to wait 1 or 2 years. This was the earlier situation. But now dependency on these kind of critical alloy material itself reduced. Please mute somebody, I think unmuted. It will be echo. If you unmute, it will be echo, please. Next is the production time. I just want all of you to please mute. Next is the production time. When it comes to production time, these composite materials we can produce in the mass and fast. But machining is not like that. If we take a aluminum or any other composite alloys, we need high precision CNC, computer numerically controlled machines. You know the cost of one Cincinnati machine. Today it will be 10 to 15 crore rupees. Such a high precise CNC machine and machine centers is not manufactured in India. We need to get it from Germany, US and Japan. Most of the CNC controls are used by Fanuc system from the Japan. That procurement, time, and that operation, repair, everything matters. And such a high quality machining centers, their maintenance and their cost, power cost, electricity cost. Not only the power cost, there are some other practical issues. You may feel funny. I will share one or two of these practical issues. In the HAL, we used to use a Cincinnati machine. At that time, machine is worth of 6 crore rupees. And when machining is going on, aluminum parts or machining is going on, suddenly power will go off. And for Indians, power cut or power gone, it may come in next 5 minutes or 10 minutes or half an hour, 2 hours. It is very common. Without any notice, suddenly the power will go off. But now see, actually practical machining, when suddenly power goes, still the spindle will be rotating for some time. And if you see on this is a tool, when it is power goes, the machining capability or cutting capability got reduced, and it will like a rubbing action. The cutter will be rubbing with the material. With that huge heat, aluminum material will lose the property, and sometimes cutter will stuck in the material. It is like a kind of a welding process will happen. It will stuck in the material. When almost a component manufactured, only when it is doing on the finishing, if it happened, then definitely cutting the material or removing the tool without damaging the part is highly impossible. It happened. Almost all our ISO components costing at that time, one component costing 1.5 crore rupees. We lost that component because of the power cut. A sudden power went off. And to spend the power, huge generators. Nowadays, generator also improved, and a lot of technology improved, power cut got reduced. But at that time, 25 years back, HAL is not affordable to use the generator, because such a generator also will take some time. Shifting will happen. 15 to 30 seconds, there will be a gap. Even that happens, CNC machines will fail. And another practical problem, suddenly power goes, not only the cutting machining problem, entire CNC machine computer parameter will get reset. When the power comes, again we have to restart the machine. We cannot continue from wherever we left. Again, we have to lift the tool. We have to go dial the reference. We have to set all the parameters, come back to the original position. That will take huge amount of skill and effort. For this problem, when we complained the Cincinnati manufacturers, he asked only one question: how power can goes? It is highly impossible to go the power. You people are kidding. There is no chance of power failure at all. Okay, such a kind of a country-based local factors also will matter, and the power cost of the power, especially electricity cost. As you know, the power generation cost is increasing like anything. We have never seen the power generation cost decreasing or stable for quite some time. Always it is keep on increasing. Whatever the technology comes, solar technology comes, other air, lot of other technology comes, and we are implementing non-conventional power, we are generating, but still our power cost is more. When we go with solar aircraft or solar aerospace applications based on the solar energy, then definitely operating cost will come down. But to generate the solar cells, we need a classic materials to use to generate the solar power or any other kind of power. For that also we need the materials, a new age materials. That is also one of the challenge and opportunities. And material property retention, like all your civil and mechanical properties in the high cyclic load and long exposed environmental condition like marines or the spacecraft, erosion, corrosion, and other natural forces will be a very challenge. Because nowadays the biggest operating cost, one of the biggest operating cost is the maintenance cost. It is not like that in any automobile or anything. We can go and check it and replace or break down, we can replace. No, not like that. Nowadays, your car also 6 months once periodical maintenance you have to go. They check it. If they found any leakage or any wear and tear, they will ask you to replace. If you use a car for 10 years, the total cost you invest on the repair and operation will be almost all 50 times more than the car original cost. Then can you imagine how much is the operation cost? Next biggest challenge is the easy repair. Because one commercial aircraft stays 1 hour in hangar, several lakh rupees will be the damage. So repair should be very fast, very easy. When I was in HAL overall division, sometimes night aircrafts will come with the bird hit or other repair. We do not have much time. We have to repair as early as possible. For that, sometime we need the machining components. We need to machine the components. So at that time, machining, if it takes time, we cannot land the aircraft for 4 or 5 days or a week kind of thing. We have to keep all those things easily repairable. Repairability is second or one of the most predominant factors. Then assembly. Assembly sometimes I feel it is the most precise and most accurate process. But sometimes with my practical experience in HAL, I feel sometimes it is a fun also. See how this will work means while designing the components, the designer will call for a tolerance. For example, normally all the aircraft components based on the usage will be called for 10 to 30 microns tolerance. As the tolerance increases, then the cost of manufacturing increases and production time will increase. and inspection requirement will increase. Okay. After we manufacture components with the 10 micron accuracy, when it reaches the assembly, then what will happen? Sometimes that will be a fun. To be honest with you, it will be a fun. Sometimes parts are not easily getting assembled. Sometimes they used to little bit force they need to use. At that time, they lose this precision, 10 microns, gone case. So such a lot of difficulty in assemblies also will matter. Then machine tools, designing, manufacturing, operating, maintaining such a precision, high cost machine tools. Technology of machine tools will be another important factor. And precision machines and automates, because something and all it should be machined and assembled by the automates only. It is very difficult for the human thing to reduce the time and to increase the accuracy and functional efficiency. And tolerance. If you go for the composite or other material, then tolerance will be okay, very easy, because you need not to machine. So attaining the tolerance in composites will be easy compared to machining components. Then the skill set of the operators are human, technology, running or operating cost of the hangars, assembly, manufacturing, storage, transportation. All this will play the key things. What I suggest for the people who want to enter, who are looking for a business opportunities, they can select one of the challenges, whatever we listed here. They select the challenges, and whatever they're interested, they can start innovation, development in these areas. For example, machining cost of aluminum alloy. You know, somehow this aluminum alloy machining cost, if you reduce 1%, only 1% machining cost, especially the power required for the machine tool, current required for the machine tool. If you 1% of the consumption of electricity, if you reduce, globally the commercial value of that 1% will be $7 to $15 billion globally. Can you imagine? To make it simple, if we reduce the hardness of that aluminum alloy without affecting any of the mechanical, chemical, and other engineering properties, if we reduce that hardness 1%, and if it is able to consume less current by the machine tools, the global commercial value will be $7 to $15 billion. You need to select these challenges, and you need to nail down what perspective you want to develop, what innovation you want to do, what research you want to do, what is the global impact if you are successful. Keeping in that mind, doing the research or finding the business opportunities have more value. Also, initially there will be difficulties and challenges, but as you people, engineering people, when you're coming forward, you may feel that initially you may not be earning that much like a software industry do or a software person will do, but in the long run, software people can sustain only for some time. In the people or in the technology sector, they cannot sustain for the long time. But aerospace is not like that. There will be a long period sustain, and there will be a long period development will be there. So now, first part is completed. The major, what I want to tell you is completed. In the second part, I will just give examples of some of the material used in the aerospace. Right now, it will take another maybe 30 minutes. In case if you want to have a 5 minutes bio break or any break, I am fine. Please let me know. Raja ready? Shall I continue or you people want break? I'm not able to hear you, anyone.
Yeah.
I hope then I will continue. Please, all of you mute. I will continue for next half an hour.
You want to
Okay.
you want to have a break and continue? It's
I'm
up to
asking you
if you
people.
want to have a break and continue, because the session is planned up to 11:30.
Sir, you can please continue.
Okay, fine. Thank you. I will continue. Thank you very much.
Sir, one request. Can you make the presentation full screen?
I repeatedly telling already I made full screen.
Okay. Okay, sir.
Okay, next coming to second part of the session. I'm not covering all the material. Some of the key materials used in this decade aerospace industry. This copper chromium alloy, copper chromium, zinc chromium alloy, copper aluminum oxide, aluminum silicon alloys, especially aluminum silicon alloys more used. So copper tungsten. All these are the few of the important materials used. So titanium 5553 is another metal that is reasonably new to aerospace, exhibiting very high strength, lightweight, and good corrosion resistance. Major structural components that need to be stronger and lighter than previously used stainless steel or aluminum the tungsten alloy. Composite material also represent a growing piece of aerospace material pie. They reduce the weight and increase fuel efficiency while being easy to handle, design, shape, repair, transport, etc. Once only considered for light structural pieces or cabin composites, but nowadays it is considered into several components, including the fuselage skin or aircraft cover, outside covers, some of the engine parts, including some of the landing gear parts also, now they started using. Important composite can be formed into complex shapes. For metallic parts would require machining and create joints. But for these composite components, joints are very less and no machining we can develop by formations. Preformed composite components are not just lightweight and strong, they reduce the number of heavy fasteners and joints like bolts, nuts, weldings, joints, all those things, which are potential failure points within the aircraft. Because of high erosion and corrosion, these fasteners failing will be very critical. In doing so, composite materials are helping to drive an industry-wide trend of fewer components in overall assemblies. Especially, it reduces the joints and the fasteners. It helps a lot in the erosion and corrosion resistance. Next generation material include ceramic matrix composites. Okay. This is very emerging, a very practical material. CMCs are comprised of a ceramic matrix reinforced by a refractory fiber such as silicon carbide. They offer low density per weight, high hardness, and most importantly, superior thermal and chemical resistance. Like carbon fiber reinforced polymer, they can be molded into certain shapes without any extra machining, making them ideal for internal aerospace engine components, exhaust system, and other hard zone structures, even replacing the heat resistant super alloy materials. So next, polymer nanocomposites. Various nanocomposites have been used with success in the aircraft construction as builder material to enhance the properties. The most commonly used one are carbon nanotubes, nanoclays, nanofibers, and graphene. These carbon nanotubes have gained more popularity for their use as a filler in the various polymer due to their exceptional stiffness, toughness, and unique electrical properties. The CNT electrical properties were utilized for the advanced electrostatic charge dissipation and electromagnetic interference shielding of the satellite. These nanoclays are used in frequently in the aerospace manufacturing due to their flame retardant properties is combined with their high strength, low weight, and relatively low cost. Then tribological and anti-corrosion coatings. This is another key critical field of aerospace materials. By adopting the nano coatings such as magnesium alloys to increase the durability of the metals. In one hand, magnesium alloys are far higher than steel or aluminum. However, they are compromised by their susceptibility to the corrosion caused by the high chemical reactivity of the magnesium. The most widely implemented solution to combat the corrosion is to use a surface coating. However, the chromium-based coatings are favored by the manufacturers. Now, nanomaterials used as an alternative to the chromium as an anti-corrosion coating includes silicon and boron oxides and cobalt phosphorus nanocrystals. However, a suitable coating for aluminum widely used in aircraft structure due to its performance to chromium is yet to be developed and poses one of the most pressing challenges for the sector. This is another key thing, erosion corrosion. Developing a anti-corrosion coatings is not only for the aircraft. Today, it is very much applicable to the marine or automobile or anything. You take your own mixie, your own ordinary machines, people who are staying in the coastal areas, it is the biggest challenge. The heterogeneous surface of aluminum renders it particularly vulnerable to corrosion, the rate of which is further accelerated by the inclusion of aluminum elements and precipitates. Current research has identified magnesium nanocomposites as a promising alternative. Nano coating being used to prevent chemical corrosion, also applied to mechanical components that are subject to high temperature and friction wear, such as turbine blades. So these coatings can drastically lower the friction coefficient and improve the resistance to wear and tear, significantly improving the engine efficiency and helping to reduce the fuel consumption. Many nanostructure and nanoscale coating material have been suggested as possible friction modifying agents, including carbides, nitrides, metal, and various ceramics. Nanocrystalline material, lighter structural material, more efficient engines. The uniting goal being to curb fuel consumption and carbon emission associated with the aerospace. The potential nanomaterial and nanoengineering have in helping to achieve these goals, especially to reduce the carbon, because to reduce the fuel consumption. Compared to the material, not only thinking about the aircraft, you think about the space shuttle, rockets, and the missiles, all those things, how much fuel they consume, how much carbon emission they produce. Compared to the material with a more conventional grain size that is larger than a free micrometer, nanocrystalline materials show increased strength, high hardness, extremely high diffusion rates, and consequently reduced sintering times for powder compaction and improved deformation characteristics, means seasoning times. So next, another exceptional advantage by polymer nanofilter is their inherent defect-free structure as a crystal level. All the metal-metal alloys, the crystal structures, defaults or defects in the formation of the crystal structure will reduce the strength of the material. That is another key area, or we need to have a very strong high metallurgy. As a result, their resistance to deformation is far superior to that for larger polymers. Considering the extreme load aerospace vehicles are subjected to, this has the potential to reduce the time and cost incurred for the maintenance. Properties crucial to aerospace application, primarily yield strength, tensile strength, corrosion resistance, and low density to facilitate substantial reduction in the structural weight. All these things will be achieved by a nanostructured titanium nickel alloy, which is a combination with extraordinary yield strength and superior super elasticity. Key requirements of the industry. If you see a summary, what is the key requirement of the industry? Complicated thermal management, impact of material properties due to huge amount of electricity to reach hypervelocity, stress, time, temperature, and environmental media during usage, machinability, energy and material efficiency, and also which leads to the extended part line. See the how it got developed. Single materials to composite materials to nanomaterials. This is the path. Then what is the next from nanomaterials? What is the future? So conclusion, the aerospace sector drives innovation in many industries. High performance military and transport aircraft require exceptional materials which will eventually their way into commercial vehicles. Finally, once you start in the aerospace, that will reach to the common household. This is the broad applications, opportunities, and challenges of the aerospace material in today's modern industry. That's all from my side. Now we will go for the question and answer session. So thank you very much for all your support and interest in this program. If you don't have any question, then we will close the session.
Any questions from the audience, please?
Yeah, I think Raja Reddy, you can conclude it. I think there are no questions from the audience.
Yeah, we are concluding it. I'm looking at the chat box. No questions in the chat box also. Yeah. Okay. Yeah, so thank you, Mr. Kirti Shekhar, for your valuable time and also very good knowledge sharing session. We are sharing the feedback link in a short while from.
So thank you one and all. All the best for your future endeavor.
In subject knowledge, equally important knowledge are the requirements. ಇನ್ನೊಂದು ಸಲ ನೀವು question ಕೇಳಿದ್ದು.
Left already.
ಬಿಡಿ ಅಷ್ಟೇ.
So if you have any questions, you can share it in the group. We will forward it and get you back the answers, because the resource person is already dealing from the session. So if you have any particular questions to be answered, let us get across and give you the answers. And post the answers, same questions in the group. We will let you know the answers.
Yes, they can take it.
How will you share the link? We'll answer. Yeah, good afternoon, good morning, everyone. This session still being open,